Good evening, YouTube. I've had this Ensupra power meter. I've been using this for I think about 7 or 8 years. It still works fine for normal operation. I use this on my small grid tie inverter. This monitors the amount of energy produced each month, and that again works fine, except if there's a power failure, it resets the kilowatt hours back to 0. So apparently there is a small battery in here, a 3.6 volt nickel metal hydride. Supposedly looks like that, and apparently that's the backup battery. So I thought, it's June 30th tonight, so I've recorded the power reading for the month, or the energy reading, and I figure I'll try swapping the battery out tonight, and then we'll try it in the morning and see if it works here. Okay, there we go. Found a good screwdriver. I think these other ones were a little too pointed. This one's kind of worn out, and it usually doesn't work, but it was the perfect fit for these screws. So anyway, got that. Yep, there's the batteries. Yeah, so I'll put a link to the video that Lawrence Francis made about a year ago where he repaired his Kuman meter that looks exactly like this Ensupra meter. So I'm not sure who's the actual manufacturer of these, but he had the exact same batteries, and I ordered the batteries off the eBay link that he posted, and that looks the same. So let's check the voltage here. Supposedly plus is on the inside or towards the middle. Oh yeah, there we go, 1.234 volts. That is why it doesn't hold memory. So this is basically the memory backup battery. And you can see the new battery here is 3.8 volts right there. So yeah, I think that is the problem. Otherwise the meter works fine. It just, if we lose power, I lose my accumulated kilowatt hours for the month. So now I think I need the small screwdriver here. There should be 2 screws, I think. Yeah, so there's your current shunt right there. So that's what measures your AC current. Looks like there's a crystal for the display, a crystal for the onboard power chip. That's probably your capacitive dropper. This creates the low voltage power supply for the chip. It's a little hard getting this apart because you've got these really heavy gauge wires. Yeah, there's the chip on the bottom there. There's a solder terminal there and one over here. Okay, yeah, I got one side of the battery out. There's a diode that sticks out, and you have to get around behind it to get to the battery connection. This side over here is okay because the battery terminal is on the outside, but this one you had to kind of come in from an angle. I couldn't see that before. Okay, there we got the battery out. You can see plus and minus there, so that was the correct polarity. Okay, success. It was actually pretty easy to get the battery in. Just spread the terminals or the pins apart so they line up straight with the 2 holes, and then I just got the pins into the recesses in the circuit board, pushed down with 1 finger, and then just touched the soldering iron to the pad on the back, and got the negative side in about halfway, and then did the same on the positive side. It pushed in all the way and then went back to the negative and pushed it down, and then just had to touch up the solder joint there. Cleaned off some of the flux, so I think we're good on the battery there, 3.8, so it's not shorted or anything. Okay, looks like it works. I don't know if this will actually work with the memory, but let me go in here. This is my trick that I use on these. So if you hold the cost button down, it'll flash. Yeah, there we go. So I'm going to set the cost to $1 per kilowatt hour, or 1 unit. And this screen here reports your watts and then the cost. But since my cost is 1, every kilowatt hour adds 1 here, so I get watts plus kilowatt hours. So let's see, we should have that stored here. If I walk through, there's kilowatt hours, volts, low, high, and there's my cost. And then we'll go back to that screen. Now I'm going to turn off the meter. So now let's turn the power back on, and we'll walk through here. Kilowatt hours, there's volts, high, low. Hey, we got it. It remembered the cost. So the memory is fixed. And let's see, let's look at the volts. So you can see my bench meter is reading 120, and this is reading 120. Wonder how low this thing will go here. That's about 110, 110.5. Let's go down to like 90, 90.5. Yeah, you know, within a half a digit. Oh, there's 80 volts. There's 70. Oh, you can see it. It's probably getting right to right to the limit. 70, and then it drops to 50. So yeah, I guess 70 volts is about the bottom end there. Let's go back up to 120. Hey, I think we got her fixed. So now I can plug this back in, and starting tomorrow, July 1st, it'll be recording power. So let's see, last month in June we had 72.35 kilowatt hours for the month from the grid tie system, and now I don't have to worry about losing the data in the middle of the month. Put a link to Lawrence's video. He goes into a little more detail on the battery, and he also checked some of the capacitors and whatnot. His meter, he was having bad voltage readings, and I've heard other people have the display might go out, and replacing the battery fix the display. So I guess depending on how bad the battery gets, it might cause the power chip in here that's reading the power. I guess if that battery goes to 0, it probably shorts out the memory pins, and then it doesn't operate at all. So yeah, there's how to fix one of these. This thing, like I say, I think I bought it in 2014. And it's been going 24/7. This has been plugged in around the clock. All my data has been recorded on this meter, but if I got a different meter, it might read a different kilowatt hours. So anyway, I figured repairing the old meter, since it worked, is a better fix. So yeah, I'm going to go plug this in, and we'll be up and running tomorrow morning when the sun comes up. So yeah, if you found that helpful, give the video a thumbs up, and as always, thanks for watching.